We're asked here to sketch a region that is defined by more than one inequality. So we have this rule here and this rule here. So what we need to do is the same process as we did in the last example, where we actually use this inequality and do it with a second inequality. We can use the calculator to help us. So let's go. So what we're going to do is remember, first of all, our first step is to express in the form of y equals mx plus c, and then we sketch that on the calculator. Now, one of the cool things that I didn't show you in the last example is we can actually put this, the less than or equals to or the greater than signs, into this form and let the calculator do the work for us. So let's have a go at that. First of all, I'm going to go to main, and remember the way to do this is to enter the equation and then solve for y. So I'm going to write that down so we have our steps all there for us, and then we'll be able to sketch them when we put them in our graph. So my equation is 4x plus 2y is less than or equal to 5. So I'm going to go to the keyboard and I'm going to go down to one of these maths functions, and you'll see maths 3 has less than or equal to, and then 5. So what I'll do is I'll solve that the way I normally do, which may or may not be the same way that you normally do it, and I'll solve it for y, and I get the answer of, well, this probably doesn't look awesome. That's because I'm in standard. So let's click back to decimal and hit go, and I get this answer here. So I'm going to write that down. So for my first equation, let's do this one in orange, I get y equals, y is less than or equal to negative 0.5 times 4x minus 5. That dot up here is a times. When the dot's on the line here, down below, that's a decimal point. So you need to have a look at where the dot is. Remember, the flying dot is a times, and the dot down the bottom is a decimal point. So now for the next one, I need to solve x minus y is greater than 1 for my y. So I'll put that in as well. X minus y is greater than 1, and I'll solve this one. Interactive calculation, no, interactive equation inequality, solve it for y, and I get y is less than x minus 1. So let's make that green, and I know my green equation is y is less than x minus 1. So now I've expressed my equations in the form of y, and then that can be equals, greater than, less than something, but y and then mx plus c. Now what I need to do is sketch them. So I'm going to go to my graph function on my calculator. And if we go graph and table, I have here my table. Now, the first one is y is less than blah, blah, blah. You know what? I'm not even going to write the sign in yet. I'm just going to write here negative 0.5 outside of 4x minus 5. For the next equation, I'm just going to write in x minus 1. Now, they're inequalities, so I need to make sure the inequalities show. So now I need to turn this into a less than or equals to. And if I hit the equals sign, it gives me the option. So then I'm going to hit less than or equals to and say OK. For the second one, this is just less than. So I'm going to hit the equals sign again and make it into a less than and say OK. So now it has replaced my equals signs with my inequality signs. And you can see here, it's going to use a solid line for the less than or equal to and a dotted line for the less than. And then I press go, and here are my two regions that I need to show. Therefore, I can now see that my purple region is the region that is desired. It is both less than the blue line, remembering that the calculators put this line in blue, and it's less than the red line, remembering the calculators put this line in red. So now what I need to do is I need to sketch this area, this region. Now before we do sketch, there is one thing to keep in mind. It's possible that we might have 3 or 4 or 5 different rules, and that starts getting annoying when I need to find the space that is the defined by the equality that's the common inequality of 4 or 5 different regions. So what I can do is I can make my calculator just show the one we're looking for. And if I go up here to this little pointer, I can come down to my formats and have a look at my graph format. And you can see here the inequality plot says union. That means it's going to shade in every single thing that conforms to any rule. If I change that to intersection, then what happens is when it redraws it, you can see it takes away anything that's not actually part of the intersection. So I can very easily see that the area that is defined by both of these inequalities is this one. So now what I'm going to do is I'm going to go to analysis and start having a look at our graphs. Now the first thing I've gone to, notice, is analysis and trace. And when I do that, I can move my cursor around using this to find different points. So I'm on the y-axis here. I can find my point of intersection is at 2.5 for my blue line, and it's at -1 for my dotted red line. So 2.5 for the blue and -1 for the dotted red. Now what I'll do is I'll start finding out where these lines intersect and some other information. So let's go analysis and G-solve, and what I'll do is now I'll go to intersection here. When I hit intersection, you can see the calculator tells me the coordinate of intersection is 1.16666 and the y coordinate is 0.1666 and so on. These aren't exact numbers. Hopefully the examiners will let you show the point of intersection to 2 decimal places. So I'm going to write that down here. I'm going to say intersection is the x is 1.17, the y is 0.17. I got those numbers from here's the x, here's the y, and I've rounded them off. So I know that. I also know the y-intercept of each of these lines and the x-intercepts of these lines. Remember from my previous example, I had my orange line, which I've done here. There's a 2.5 there and a 1.25. And for my green line, it was -1 and +1. So now what I'll do is I'll draw my lines in. Of course, I'm going to use my ruler because I make sure that I get everything perfect when I do that. So there's my green line. The next one I'm going to use is my orange line. So I will just get out an orange pen and do that. And of course the orange pen, again, I'll use my line and I will rule it so it looks something like that. And let's just straighten it up a little bit so it goes through my dots. And there we go. Maybe just bring that down so it goes through my dots. Beautiful. So there are my 2 lines. I know that my point of intersection is at 1.17 and 0.17. I know that my intercepts here are 0 and -1, and here, let's put it in there, 1 and 0. I know my intercepts. Notice how I'm labeling all the intercepts. It's really important you do that. You need to show everything about your graph. Here, the graph should probably be a bit bigger than this. 1.25 and 0. My graphs, it's pretty clear which graph's which on this. And my labeled region or my desired region, let's put that in yellow. Look at how well I can colour in here. Is this region here. And there's one thing I've forgotten to do, and that is that the green line is actually a broken line. So I need to make sure I put my little notches in the green line so that shows that that line is not included in the region. And that's how we sketch an inequality that's defined by 2 different rules, and we use the calculator to help us do it.